Hello everyone and welcome back to the 11th episode on how to create your own programming language in Python. So first of all, sorry about the long delay since the last episode and I hope to get a lot more videos out now in the summer. So in this episode we are going to be adding in lots of built-in functions into the language. Before we get started with that, I just want to come down to the global symbol table here and move the null, false and true values into their own constants. So we're going to change null to number.null, we'll change false to number.false, and then true to number.true. And now we'll go under the number class and we'll create those constants. So number.null will be equal to 0, number.false will be also 0, and number.true will be 1. So now we're going to head over to the function value class, and we're going to be creating a new built-in function class, and this will share a lot of the same code as the function class. So we're going to create a subclass called base function, and we'll put a lot of the shared code in there which can be used by both function and built-in function. So we'll create a base function class, and in the init method we will take in a name, and we can assign that to either self.name or anonymous if it doesn't have a name from the function class. And we also have to call super.init above that. So when we execute our function we have to create a new context, and we're going to move this into a generate new context method. So we're just going to grab the code here to create a new context, and we're going to just paste that here, and this method is just going to return the new context. So next we are going to create a check args method which will take in the argument names and the arguments themselves that are passed in. And this method is just going to check that there are the correct number of arguments, so we can get this code from down here. So we'll paste that into the check args method. So we will replace all the self.arg names with just arg names. So that will be here, 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 and here. So we're also going to have to create a new runtime result, and at the end of the method we can just return result.success and pass in none, because this function doesn't return anything. So the next method will be populate args, and this will just put all the arguments into the symbol table. So we're going to need the argument names, the values, and we're going to need the context which has the symbol table which will be putting the arguments in. So we can just grab the code for this function from down here. So we'll just copy this and we'll paste that in, and we're going to have to change self.argnames to just argnames. So we're going to have one last function called check and populate args. So this will just check the args and populate them. So we need the arguments and the context again. We'll start with a runtime result, and we want to call both the check args method and the populate args method. So we'll start with check args, and we'll pass the arguments in. We'll wrap that with result.register, and then we need to check for errors. And now we'll call self.populate args, and we can pass in the arg names, the argument values, and the execution context. So finally we can just return result.success, and we're not returning any value, so we'll put in none. Okay, so that's it for the base function class. So now we have to update the function class to use all these methods from base function. So first of all, we no longer need to set self.name in here, that's done in the base class, so we'll just pass in the name. We can now remove this context code here and just call self.generate new context. We can replace all of this with just self.populate and check args, or check and populate args. So we'll pass in self.argnames, the arg values, and then the new context. And actually, to be more clear with the variable name, I'm going to rename this to execution context, because that makes more sense. So we can then wrap this in result.register, and we'll again check for errors. I just spotted a mistake in the populate args method, so this execution context variable name needs to be used here and here. So now we need to make function inherit base function, and now we can move on to the built-in function class. So we'll create a new class, built-in function, and this will also extend base function. So we'll just create an init method which will take in the name, and we'll call the super init method with this name. So we're going to need to overwrite the execute method. So we'll create a runtime result, and now we're going to create a new execution context. So we'll call generate new context. And what we're going to do is create separate execute methods for each built-in function. So if the function name is print, for example, we'll call execute underscore print. So we'll create a variable called method name. So this will be execute underscore the method name. So the method name is just self.name. So now we can get a handle of this method by calling get attribute. So we'll pass in self, the method name, and we'll pass in a default method of self.noVisit method. So this will be called if we forget to create a method. So this method will just raise an exception. So now we're going to use the check and populate args method again, and we're going to pass in method.argnames, and you'll see what this means in a minute. And then we can pass in the arguments and the execution context. So we'll check for an error, and then we want to call this method. So we'll set return value equal to result.register, and we can call the method with the execution context. So we'll check for errors again, and now that we have our return value, we can just return this. So return result.success return value, and that should be it for the execute function. So like all the other value classes, we also need a copy method and a representation method. So now we can finally get started with creating all the different built-in functions in our language. So we're only going to be creating a small handful of functions in this video, but feel free to add a lot more functions because we only have a few here. So we have a print function, we'll have a print return function, which just, instead of printing it on the screen, it will return the value that's being printed. We'll have input for string inputs and input int for integer inputs. Clear will clear the string, and then we have all these is methods for checking the types of variables. Append will be a mutable function which will add an element to a list. Pop will remove an element from a list, and that's also mutable. And then extend will concatenate two lists together, and that is also mutable. So you could add in a lot more functions such as file management functions or mat functions such as square root, maybe a function to get a random number, etc. There's a lot of things you can add, but I'm not going to waste too much time doing that in this video. So what we'll be doing is creating an execute method for each one of these functions. So we'll start off with the print function. So we just have to take in the execution context, and what we can do is set execute print.argnames equal to a list, and we can put in all the arguments we want in this function. So we want one argument called value. So the reason we can do this is because for the argument names we're getting the argnames property off the method. So that's what we have here. So to get the value we want to print, we're going to get the execution context symbol table, and this is going to hold all the arguments that have been passed in. So we can just call .getValue to get the value argument. So once we have this value, we can convert it to a string, and then all we have to do is just print it onto the screen. So now we need to return a runtime result success, and our function isn't returning anything, so we're just going to use number.null. So that's actually it for the print method. So now we're going to do the print return method, and instead of printing the value onto the screen, it will return the value that should be printed. So we'll just copy and paste this method, and we'll change it to print return, and we're still taking in a single value, and this time instead of returning null, we want to return the value we're printing. So we can just take this value that we're printing from here and remove the print statement, paste that in here, and we need to create an instance of our string value class. And that should be it for this function. So next we have input. So we'll use the Python input method and assign the result to the text variable. And all we want to do is return this text. So we'll return a success, and we'll create another string instance with this text. This method isn't going to have any arguments, so we can just set the argnames value to an empty list. So we'll copy and paste this function, and we're going to create an int input as well. This time we want to try convert this value into an integer. If this fails, we're going to catch that in an except statement, and we're just printing out that that text must be an integer. So instead of returning a string of text, we want to return a number of number. If the user does not type in a number, we'll just keep reprompting them to type in a number, so we'll just wrap this into a while true, and if it successfully converts to a number, we can just break out of this loop. So that should be it for the int method. We're now going to create a clear method which clears the screen. We are going to need to import OS for this function. And now we can call os.systemClear to clear the screen, and this command only works on macOS and Linux. On Windows we need to use CLS. So we'll use CLS if os.name is equal to Windows, but otherwise we'll use clear. We'll again return null because this function doesn't return anything, and we'll set the argnames to an empty list again. So now we're going to create a few functions to check the type of variables. So we'll start with isNumber. So this is going to need a single argument, and we'll call that value again. So the way we'll check if it is a number is by calling isInstance. We'll get the value from the symbol table, and we'll check if it's a number. So now we want to return the boolean true if it is a number, but otherwise we want to return the boolean false. So I've just copy and pasted this method 3 times, and we've created another one for string, list and function. So we're just checking instead if it is a string, a list or a base function, and the reason we're using base function is because it could be a normal function or a built-in function. So next will be the append function. This function will just append an element to a list, so we want 2 argument names, list and value. We'll start by getting these 2 values from the symbol table, and we'll just check if the first argument is not a list, and if it isn't we will just create this error, first argument must be list. If it is a list we can just get the elements from this list and append the value. This function once again doesn't return anything, so we'll just return null. Okay, so we have 2 more methods left, pop and extend. So we'll start with pop. This function removes an element from a list depending on its index, so we need 2 arguments again, list and index. So we'll get these 2 arguments from the symbol table, and I'll just paste in these 2 checks to check that the first argument is a list and the second argument is a number. So now we can just do list.elements.pop, and we'll pass in the index, and we can assign the element that's popped to element. We'll wrap this in a try-catch block, and this will fail if the index is out of bounds. So now we want to just return the element that we've popped. So we'll move on to the final method now, and that's extend. So this method is going to take in 2 arguments, which are 2 different lists, and it will concatenate the elements in list B into list A. So we'll once again get the arguments from the symbol table. We'll check if both arguments are lists, and if that's the case we can get the elements from list A, and we can use the Python method extend to extend the elements from list B. And this will once again return null. So that is it for all the different built-in functions. So now we're going to add all this to the end of the built-in function class. So we're just creating a constant for each built-in function, and we're just assigning that to a built-in function with that function name. So now we can come down here and add all these functions to the global symbol table with the corresponding names. Also remember that you can add more than just built-in functions into the language, you can add built-in variables as well. So if we wanted to say, for example, add a matpy variable, we could add that with a value of number.matpy, and then we could just come up to the number class and set matpy to a new number with the value of mat.py, which also means we have to import mat. So just a small mistake here in the input int function, this input call should be in the while true loop, so you can try again. So just a couple of things we have to do before we run the program. So in the list class we have to come down to the copy method and remove these couple of characters. So the copy method is called every time a value is passed into a function or a value is assigned to a variable, and in our language we don't want it to copy the list when that happens, so we have to remove that copy part here at the end. The other thing we have to do is inside the visitVarAccess node method of the interpreter, when we create a copy of this value we forgot to update the context, so we just need to add this in. And finally inside the visitCall node method we forgot to do this entirely. So we need to set return value equal to return value.copy, and in this copy we need to update the positions and the context. So we should hopefully be ready to run the program now. So if we run the program now we'll have access to all those new built-in functions and also the matpy built-in variable. So we'll start with the print function, and there is a slight problem with this function at the moment. So as you can see when we print it out it's actually including the quotes in the print, so we will fix that up in a minute. So we also have input, so if we do var name equal to input, now we can type in our name, and as you can see this value is now assigned to the name variable. We also have input int, so if we assign that to age we can now type in an integer. Now if we don't put in an integer it's going to prompt us to do it again. So once we type in a valid age, as you can see that value is now assigned to age. So the next function we have is clear, and let me get out of this prompt. And as you can see that clears the screen, and we can also use CLS to do the same thing. We can check if a value is a number, so if we put in 1, 2, 3 that will return true, but if we put in a list for example it will return false. We also have the same for isString, isList, and isFunction. We can also append elements to a list, so if we create a list with the values 1, 2 and 3, we can type append list with the value 4, and now as you can see the list has 4 in it as well. We can use pop to remove an element from a list, so if we do pop list and we want to do index 3, So index 3 means the fourth element in the list because it starts at 0. So if we run that, as you can see, we've popped 4 from the list, and if we type in list now again, it only has 1, 2 and 3. And finally we can use extend to concatenate two lists together. So if you extend this with 4, 5, 6, now our list has 1, 2, 3, 4, 5, 6. So that's it for the built-in functions, but now we want to just quickly fix that print function to not show the quotes. So what we're going to do is come over to the string class, and we're going to add in a new method called underscore underscore string underscore underscore. So instead of returning a representation which shows the quotes, it will return what it should look like when we print it out. So all we want to do is return self.value. We're also going to do a similar thing for lists, so we'll add in a new string method. So we'll copy and paste what we have from the representation method, but what we want to do is remove the square brackets from the print version. So if we run the program again, we can now print out a string, and we will not see the quotes. And if we print out a list of strings, foo, bar, elephant, it now looks a lot nicer. So everyone, that is going to be it for this episode. I hope you enjoyed. If you did, don't forget to leave a like. So in the next episode we are going to be adding in multi-line statements to the language. So this means we'll have multi-line functions, multi-line if statements, etc. And for now we're going to use semicolons instead of new lines until we move our input into a file. So I hope to have the next episode out soon, and I will see you all then.